So today we're going to talk about the book Real and Complex Analysis by Walter Rudin. Let's start with the prologue, the exponential function. This is the most important function in mathematics. It is defined for every complex number z by the formula exponential z, exp z equals to sum to the infinity z to the n divided by n factorial. So we also have that, see, there's the deduction, like a to the k divided by k, k factorial, and sum to the infinity. So if they are multiplied, it actually equals to this. So how do we get this? We actually get this by the binomial formula. Yeah, yeah, that's binomial formula. So here we get that expa times expb equals to expa plus b. And we define e to be exp1. We usually replace expz by the customary shorter expression e to the x. Notice that e to the 0 equals to exp0 equals to 1, which is a very fact thing, right? So for every complex z, we have e to the x doesn't equals to 0. exp is its own derivative. Notice that exp is not e to the something, because like e to the 2, if you derive it, it's 2e to the 2. So exp is actually different from e. And it is a monotonically increasing positive function, e to the x to infinity as x to infinity, and e to the x to 0 as x to the negative infinity. There exists a positive number pi such that e to the pi I divided by 2 equals to I. So y we can find here, right? So if that is e pi, like I there and t equals to pi divided by 2, and we have cos pi divided by 2 plus I sine pi divided by 2. So we have cos pi divided by 2 equals to 0, and it's crossed out. So we have now I, and sine pi divided by 2 is obviously 1. So I pi divided by 2 equals to I. Yeah, that's the answer. Also, we have that the absolute, no, it is the norm of e to the it equals to 1. We can't see here because, like, if we want, so this, yeah, we can pretend it is a complex number thing, and that's the how to say this? Oh, it's absolute value. No, it's the distance or something, whatever. Like, it's equals to the conjugate times itself, and then we have 1. So we now root it out, make a square root, and it is finally 1. Cos t equals the real re e to the it. This is obvious, right? Like, we have this, and here's cos t, and sine t equals to image im, no, imaginary, sorry, im e to the it. So cos prime t plus I sine prime t equals to I e to the it equals to minus sine t plus I cos t. So obviously, it's different from exp, right? We're only talking about e here. So make sure that you differentiate e from exp. So cos t equals to 1 minus 2 factorial under t squared. I'm not gonna read that, but you guys can read it. Yeah. And now the terms of the series then decrease in absolute value except for the first one. Yeah, these are proofs. Proofs are how to say. I think I've included some of the proofs there, so I'm not gonna say that. Yeah, here you go. Bye.